What's up, math scholars? It's Tuesday and it's second period. Who is excited to do yet another study guide video today? They actually are looking awake, so this might go well. Number one, find the first 5 terms of the sequence. I don't have a ton of workspace, but there, that should help. The first term is 4. I would count that as my first term. If you want to use your calculator, here's how you can do it. 4, enter. Then 3 times previous answer. To get the answer button, second negative key. So 4 is first. I need to grab a pen, apparently. There's pen. 4. The next one's 12. And then I can click enter to get my next one, 36. I can click enter to get my next one, 108. 108. And then I can click enter to get my 5th term, 324. So any issues on 1A? All right, 1B, I could click -1, enter to get rolling, then 2 times the answer key plus 5. So -1 was first, then 3, enter 11, enter 27, enter 59. Is that my 5th term? I think so. Yep. Now in part C, I cannot simply just use the answer button. Why is that? Because an-1, that means go back 1 term. That's where I could use the answer button. But an-2, that means I have to go back 2 terms. There's no button for that. So my first term here would be, I would actually count the -3 as my first term. I would count the -1 as my second term. To get the next term, I'm going to need to do, I should have probably showed my work a little better on this. So for the next term, A2, I would do 2 times the previous term plus the term before that. So my work is -2 plus -3, so -5. The next term would be A3. I would do 2 times the previous term, so 2 times -5, plus the term before that. So it's -10 plus -1, or -11. And finally, A4. It's 2 times the previous term, so 2 times -11, plus the term before that, -5. So -22 plus -5 is -27. 2. Number 2, it says find the sums if they exist. These are all infinite sums. So what is something that you need to check on to make sure an infinite sum exists? Matthew, what do we have to check on to make sure an infinite sum exists? Yeah, you got to check that R value. Make sure the absolute value of your R value is less than 1. So on part A, I'm checking the 5/3. 5/3 is not less than 1, so it's a no sum right off the bat. No sum, 5/3 is too large. Now, part B, my last class was a little baffled. We were having a little conversation about this. Do you think all of these terms are following the same pattern, or do you think the 6 does not belong? So when I looked at it, I was looking at the 12 and 24 and 18 and 54, and I figured out they were multiplying by 2 over 3. If I do 6 times 2/3, do I get 12/18? 6 times 2/3 would be 12/3, not 12/18. So the 6 does not belong in this sequence. Let's erase that real quick. So here's what our strategy is going to be. Our strategy is going to be to find this infinite sum in the red circle, and then add the 6 on at the end separately. So I'll just do 6 plus, and now I'll do my infinite sum things. To do infinite sums, you put A1 on top, so 12/18 is my A1, and you put 1 minus R on bottom. 1 minus 2/3 is my bottom. Write that well. So I just typed it in all at once with the 6 out front and ended up getting 8. So any questions on part B? The 6 just didn't belong in the sequence. That's why I left it separately. And then finally in part C, the R value is 1/3, so that's perfect for me to be able to find an infinite sum. So I'll put my A1 on top and my 1 minus R on bottom. And if you use the fraction button, you can type it in all at one time and get 2. On this one, make sure you read the instructions. They're having you write the recursive rule for the sequence. I myself accidentally did the explicit rule because I wasn't paying attention to instructions. The recursive rule is the one where you have the initializing of the sequence. So A1 is 4. And then you tell them where to go by referring back to a previous term. So if I'm going to refer back to the previous term, I would do A subscript n minus 1. And I would tell them to add 6 each time. So this one is called an arithmetic sequence. They are adding the constant amount. I hope you guys have been with this. I don't need to be standing where I'm standing. Would this help? Okay. Number 4. Same deal. We're going to initialize the sequence by saying it is a 3. A1 is a 3. Now, did anybody actually figure out what this pattern is? Noah? Yeah, so actually when we initialize our sequence, we have to initialize the first 2. Because we're going to be referring back not only to the previous, but to the term even before that. Because like Noah said, the formula is to take the previous term. That's an A subscript n minus 1. I'm having trouble writing it. And I'm going to multiply by A subscript n minus 2. That takes you back 2 terms. So A subscript n minus 1 times A subscript n minus 2. And finally, number 5. My first term is 5. This is a very easy pattern to see. They're just multiplying by 3 each time. So I'm going to refer back one term, A subscript n minus 1, and I'm going to times it by 3. 6 and 7. These problems are iterates, so just a reminder, x0 is called your initial value. It does not count as your first iterate. So to get my first iterate, I simply take my initial value and I put it in for x. So mathematically, it's -2 times 2 minus 1. That should be -5. Does that sound okay? I misplaced my answer key that I used to check. All right, to get my next iterate, I put my -5 in for x. So -2 times -5, +10 minus 1. So that's 9. And finally, I put my 9 in for x. -2 times 9, -18 minus 1, -19. That counts as your first 3 iterates. On number 7, I'll take my initial value and put that guy in. 5 times -1 plus 2. That should be -3. Then 5 times -3 plus 2, -13. And finally, 5 times -13 plus 2, -63. My last class was trying to compare this pendulum problem with the ball drop problem that we did in class last week. This is not like the ball drop problem. The ball drop problem had an initial drop, which had nothing to do with the sequence. We added on later, and then it had a bounce and a drop, and a bounce and a drop. This was a double infinite series. This is just an infinite series. They release the pendulum to swing freely, 30 inches on the first swing. Each swing after that, it travels 75% as the previous swing. So it's just going to be an infinite series where we are adding up every swing from swing 1 to infinity of the geometric sequence, starting with a first swing of 30, going 75% each time. So if I use my infinite shortcut 6, A1 goes on top, 1 minus R goes on bottom, and that gives you the answer of 120. So it swings 120 inches total. Really the same type of question. 9 and 10, we need a geometric rule. So we need to know what A1 is. They're not giving this to us. We need to know what R is. They're not giving it to us. These are harder problems than they were on yesterday's study guide. We're going to write what's called a system of equations. In the first system, we know that 10 is a term. We know 10 is the second term. We don't know A1 or R, but I could put that 2 in for n. That's my equation for my first. That goes along with A2 equals 10. Now, A5 equals 80. I'm going to put the 80 in for AN. Still don't know A1. Still don't know R. But I know this is the fifth term, so I can put a 5 in for N. And this is called a system of equations. And when we solved this one in class that day, we learned the lesson. We did elimination. Do you remember how we set up the elimination? We divided these two equations by one another. And I'm going to divide the bottom one by the top because that just makes more sense. The bottom one has an r to the fourth. The top one has an r to the first. So dividing in that direction makes the most sense. 80 divided by 10 is 8. A1 divided by A1, the a's go away. That's the elimination. And then this is an r to the fourth. This is an r to the first. R to the fourth divided by r to the first is r to the third. And then you could just cube root both sides to figure out that r is 2. Now at that point, I like to plug in my r value to my favorite equation. My favorite would probably be the first one. So I'll put the 10 there. I still don't know A1, but I know that r is 2. And 2 minus 1 is just 1. So it kind of looks like this. And all I have to do is divide by 2, and I figured out that A1 is 5. Now you don't want to walk away until you've compiled your final equation. Your final equation would have your A1 of 5, your R of 2, and then an N minus 1 power. Okay? Number 10, same exact deal. We're going to write our system of equations. We don't know A1 and we don't know R. So I'll put my negative 48 in for AN. Don't know A1, don't know R, but I know that N is 3 for the first equation. For my second one, negative 3072 can go in for AN. We've got our A1 and our R. And now that we've written it out, go ahead and solve this the rest of the way with your groups. All right, so I'm going to divide these two numbers by each other. End up getting 64. My a's will eliminate when I divide, and my r to the fifth divided by r to the second is r to the third. Cube root both sides and get r equals 4. I'll plug it back into my favorite equation, which is the first one. And I'll divide both sides by 4 squared, or 16. A is negative 3. And you're not done until you compiled your equation. AN equals A1 times R to the N minus 1. All right, we're on our last one. To get the next 3 terms, we have to go 2 previous. That's what AN minus 2 means, times the previous. So to get A3, I'd go 2 terms back. Like my pen stopped working. Oh, I bumped the button. 2 terms back is negative 5. 1 term back is 2. So my third term would be negative 10. On the fourth term, I would go 2 terms back. So I'd get the 2. Then I multiply it by the previous term, negative 10, to get negative 20. And finally, for the fifth term, you'd go 2 terms back, grab that negative 10, multiply it by the previous term of negative 20, and that gives you positive 200. So those are your next 3. All right, well, we're going to end early. This is a reminder to do the 7-5 day 2 Delta Math. I extended the due date on that because so many people weren't done, but I was out on Friday, so it's understandable. There's a study party after school today and before school tomorrow. Thanks for watching the video.